Similarity proofs. Recall some of the things that we know we can mark in conjoined triangles, triangles that are joined, such as vertical angles. Vertical angles are congruent. Those are from lines that are intersecting. So we would say that angle JGA is congruent, JGA, congruent to UGH, angle UGH. Remember that it is the middle letter that is the vertex of the angle. Also, alternate interior angles. Those are the angles that when you have parallel lines, so notice that symbol, remember that that means the lines are parallel. And the symbol for parallel is like the two L's in the word parallel. In the picture, it's the arrows. We make the zigzag shape over the parallel lines, and that gives us the pair of alternate interior angles that are congruent, such as angle AJG, congruent to angle HUG. Again, remember the middle letter is the point at which we put the angle mark. Now that's not the only way we could have drawn the zigzag in this picture. We could have also drawn it this way, which would make angle A congruent to angle H, but you'll see it written the three-letter way, angle JAG congruent to angle UHG. So again, the middle letter is where we put the congruent mark, A and H. We've also got corresponding angles when we have parallel lines. So because these are the lines that are parallel, the transversal could be this one. That makes this angle congruent to this angle. So that would be angle ABD. B is the middle letter because B is where we have the congruent mark, and ACE. Again, C is the middle letter, C is where we have the congruent mark. But that's not the only pair of corresponding angles. If I draw the transversal this way, then it's these pair of angles that are congruent. That would be angle ADB, congruent to angle AEC, where the middle letters is where we put the congruent marks. Finally, remember that we can mark the reflexive property for angles as well as sides. In this picture, we've got the two triangles. So this angle right here, DCG, angle DCG, is congruent to itself in the larger triangle, ECF. C being the middle letter because both of those triangles share that angle, and that's the congruent angle. Let's use some of these in the following proofs. Example, fill in the following proof. Notice that the statements are already listed. We need to fill in the reasons. We're given these sides are proportional. We're trying to prove that these triangles are similar given this picture. Notice this statement is the same as what's given, so of course the reason is given. Angle CAZ is this angle right here, and angle SAR is this angle right here. These angles, remember, are vertical angles. So our reason is vertical angles are congruent. Finally, we have enough information to say what we're trying to prove, that these triangles are similar, as it says here. So we need to think of, when we're trying to find why are triangles similar, which of the three similarities is it? Angle-angle similarity, side-side-side similarity, or side-angle-side similarity? Which ones? Well, I do have a pair of angles, and I do have sides that are proportional. That's what this is. Two pairs, Here's a pair of sides, and here's another pair of sides. So these are the two pairs of sides, and this is the pair of angles. So side angle side, similarity theorem. Examples. Fill in the following proofs. Use the bank of possible reasons provided. So here are some possible reasons. Notice we have our three similarity postulates or theorems. We have our given, and then we have some of the other things that we just talked about. Of course, the first thing is usually given. So we look at what's given, and it says GH is parallel to MN. Let's make sure that's shown in the picture. Here's GH, I see the arrow. I'm just going to highlight that a little bit more, and MN. So the arrows remind us that these are parallel. Remember that when we have parallel lines, we can use one of these parallel reasons. When the lines are parallel, either corresponding angles are congruent or alternate interior angles are congruent. Which do we have here? Well, I can make the zigzag, G down to H this way, or I could make it the other way. I noticed the way the letters were in the statement, which is why I made it this way, because I see H in the middle and M in the middle. G, H, K, H is where I put the mark, and N, M, K, so M is where I put the mark. Therefore, I'm going to use the alternate interior reason. So I'm going to use symbols to abbreviate. When parallel, alternate interior angles are congruent. Next, I'm given the reason to use vertical angles are congruent. Vertical angles. Where are the vertical angles? Here and here. So I will say angle GKH. Notice that looks very similar to that, but it's in a different order because K is where I put the congruent mark, is congruent to angle NKM. K is where I put the congruent mark, so K should be in the middle for both. Finally, I do have enough information to say that the triangles are similar, like I was trying to prove. So which of my similarity postulates or theorems is it? Well, here's an angle mark, here's an angle mark, and they didn't say anything about the sides, so that would be the angle-angle similarity. Let's try one more. Given. Let's go ahead and write that first. And of course, the reason is that it's given. This means parallel, so let's go mark with the arrows. Here's BD and CE, and we show it's parallel with those parallel arrows. What can I use once I have parallel lines? One of these. When parallel, do I have alternate interior? That's the zigzag. Or do I have corresponding? That's the F. Well, in this picture, I can draw a transversal coming down the side, and it gives me that F-type shape, like that. So I have the corresponding angles. When parallel, corresponding angles are congruent. Which angles? A, B, D. B is in the middle because that's where I put the mark, is congruent to angle ACE. Well, I could have drawn the transversal down this side and got this pair of corresponding angles, but I'm going to try something different just for fun and to show you what else we could do. Instead of using the other pair of corresponding angles, I noticed that because these two triangles are inside each other, they both share angle A. Angle A is congruent to itself by the reflexive property of angles. So I'm going to use that one next. That would be angle A. But in the little triangle, the three-letter name is angle BAD. A is in the middle, of course, Congruent to angle, in the big triangle, it's angle CAE. And of course, A is in the middle because that's where I put the angle mark. Now, keeping an eye on what I'm trying to prove, this is saying that the sides are proportional. Well, how do I figure out that the sides are proportional? By using the definition of similarity. So I've got to say that I have similar triangles here. And I'm pretty sure we now have enough information to say the triangles are similar. Which ones? Well, this little one, if I draw it separately, A, B, D, it has this angle with 1 mark and this angle with 2 marks. And then the larger triangle, C, A, E, that has a single mark at angle C and a double mark at angle A, and that would be my angle-angle similarity. So I can say triangle BAD is similar to triangle CAE by the angle-angle similarity. Now that I know that the triangles are similar, I'm able to say that the sides are proportional. So I'm going to write the thing that they said to prove, AB over AC equals BD over CE equals AD over AE because of the definition of similarity. I have similar triangles, so I know that the sides have to be proportional. It's sort of like the CPCTC from congruent triangles. Once I say triangles are congruent, then I can say the parts are congruent as well. Oops, I just noticed I meant to use similarity symbol over here. So let's take that out and fix that so it says that this triangle is similar to this triangle. Not congruent, similar triangles. Thanks for watching.